the garden needs more grass. So
Okay.
I need you to find the area of this curve
Yes.
using this blue line to get me the area to see how much grass we have to buy.
Okay.
You know what you're going to use to find this area?
Yes.
You get the integral and then the area of the curve,
Yes, of course.
okay?
Okay. So first I have to practice integrals. Okay. So I have my integral x squared plus 1 squared times what did she said? Oh yes, of course. Dx. Okay. So I first what was I supposed to do? Oh yes. So I divide this to make it one equation. So I got x4 plus 2x squared when I distribute this plus what was it? 1. Okay. And in order to get my antiderivative, she said to use xn plus 1 over n plus 1, right? Okay. So then I have to pass my n over here. That makes 4x, and 4 plus 1 is 5 over m, so 5 plus I distribute my 4, that is 4x, 2 plus 1 is 3 over 3 plus, and because I have nothing there, just an x. And then my final answer would be 4x to the power of 5 over 5 plus 4x to the power of 3 over 3 plus x plus c. I think I'm getting the hang of it. Okay. Oh, I did something wrong. You weren't supposed to put the 4 in front, and this was supposed to be a 2, and my answer therefore has no 4 in front. Okay, so my actual answer would be x to the power of 5 over 5 plus my 2 x to the power of 3 over 3 plus x plus c. Of course, this makes sense now. Yeah. So she said that the distance was 3 meters and the equation was x minus x squared. Okay. So I have my derivative, my antiderivative, I'm sorry, 3 and 0, because that's my distance, and x minus x squared. So I use the formula of fb minus f of a. And this is my b, this is my a. Okay, now I have to get the antiderivative of this. That would be x squared over 2 minus x to the power of 3 over 3. So this is my first thing to input into my f of b. That would be for every x I have to put b. Therefore 3 to the power of 2 over 2 minus 3 to the power of 3 over 3. This all goes in brackets, minus 0 squared over 2 minus 0 cubed over 3. This goes in brackets also. And then now to solve, well, this is obviously 0. And this is 3 times 3 equals 9 over 2 minus 3 times 3 equals 9 times 3 equals 27 over 3, that is equal to 9. Therefore, I make this over 2, so 9 over 2 minus 18 over 2 equals, because this is 0, so it cancels out, so negative 9 over 2. There's my answer. Okay, so my area is 9 over 2.
4.5.
That would be 4.5 meters squared.
So how much meters squared is that area?
It's 4.5 meters squared.
Each meter is 6 pesos. So if I multiply 6 by 4.5, I have to give you 27 pesos.
Okay.
Will you go pick up that grass?
Yes, of course.
Okay, thank you.
You're welcome. Okay. So this is what I got from when I was going in my car to get the grass. Okay. I need you to tell me how did to find the distance I drove using the midpoint.
You have to use the Riemann sum. Remember, you have to find the width
and then I find the width like this.
And then divide into two subintervals.
Times my two subintervals.
Do you know?
And it's using this, right?
Yes, that's right.
It's W times 2 times plus 5.
Yes.
Okay.
Okay.
My values. There are 0, 1, 2, 3, and 4. Okay, so I get my velocities that were 0, 2, 3, 5, 5.5. So he told me to use the Riemann sum. And if I remember correctly, you find your width between these two, because I want to find these two. So my width will be equal to 2, given that each from 0 to 2 it's 2. Therefore, W times my two midpoints, x1 plus x2, will give me my distance. So my W is 2, my x1 is 2 plus 5, and that will give me 5 plus 2 equals 7 times 2 equals 14 meters. Okay. Anyway, Master, sir.
Yes.
It was 14 meters long, my journey to get the grass.
Great. It looks like you have learned math.
Of course, thank you very much.
Great, thank you.
Life lesson.
Okay, something new about Riemann sums and definite integrals. It's that they have many real-life applications. They can be applied to physics, engineering, or to find satellite orbits. They can also be applied to estimate an exports of a country when we're given a graph, and it can also be used to estimate the population growth. So this is quite interesting. This is the works cited page for the interesting fact about Riemann sums and definite integrals.